In this video, we're going to be looking at a specific type of electrochemical cell called a fuel cell, specifically looking at how a fuel cell works, and we're going to evaluate the use of fuel cells, metal ion cells that we looked at in the previous video, and fossil fuels as a source of energy for powering vehicles. So let's have a little think about a timeline of the different sources of energy we as a society have used to power vehicles historically and today. If we go back sort of quite far in time, we would maybe have used coal to power steam engines. So we would have combusted the coal, that would have released thermal energy that would then be turned into kinetic energy. That's quite an inefficient process of getting energy from the coal into kinetic energy. There's lots of waste products created and lots of the energy is dissipated to the surroundings. So it's not very efficient at all. More recently, we've been using petrol and diesel in the form of an internal combustion engine to release energy. That's definitely more efficient. There's far less particulates released, but it's certainly not a sustainable way of getting energy out of a fuel and powering the vehicle into the future. Petrol and diesel don't have an infinite supply. They're definitely finite resources. So more recently, we've been starting to create electric cars, and those at the moment are largely powered by metal ion electrochemical cells, so really similar to the ones we looked at in the previous video. Those metal ions that are used in those batteries, again, are not in hugely abundant supply. There's definitely a limited finite amount of them, and some of them, particularly the most common metal used, lithium, is quite an expensive metal to produce. Therefore, these, in terms of being a sustainable source of energy moving into the future, might not be the perfect solution for us. And later in the lesson, we're going to look at some different comparisons between these fuel sources. There is, however, an alternative which might present a more sustainable way of creating a fuel source into the future. That's to use a hydrogen fuel cell. So the purpose is to put hydrogen into a tank, just like you would with petrol. So you could go to a petrol station and fuel up with some hydrogen. That would be stored in a tank, and then that hydrogen can be converted into water. So water vapor would leave the car, and in that process, you would create an electrical current. And that electrical current would then power the vehicle by making some motors turn, etc. What doesn't happen in a hydrogen fuel cell is combustion. So at no stage is the hydrogen set alight. We're not burning it with oxygen, because that's, again, not a particularly efficient way of getting the energy out of fuel. So the reaction that happens in a fuel cell is we take the hydrogen gas, we react it with oxygen from the air to produce water, and when that happens, a large amount of energy is released. But the only product is water vapor, which is not a particularly bad pollutant gas. So we've potentially got a solution to an energy issue whereby we're creating or releasing large amounts of energy, but not producing lots of pollutants. We're also using a source of fuel that is quite sustainable. Hydrogen is readily available from water, and we've got lots of water on the planet, and we create water as a byproduct. So that process is sustainable. However, it does require energy to produce hydrogen in the first place. So depending on where we get the energy from to release the hydrogen, that might make the process less sustainable. If, for instance, I'm using fossil fuels to get the energy to break apart the water molecule in the first place to create the hydrogen, then that process is definitely not sustainable. If I'm using solar, wind power, then that process is more sustainable. We could, I suppose, rather than put the hydrogen into a fuel cell, we could try and create an internal combustion engine whereby we just set fire to the hydrogen. Now, on the screen, hopefully you can see there is an example of an airship called the Hindenburg that exploded. It was filled with hydrogen gas. Hydrogen is incredibly flammable and explosive. So trying to create an internal combustion engine to effectively use hydrogen just like petrol is really difficult because so much energy is released and it's so explosive that trying to contain that energy inside a combustion engine is really difficult. It's also a really inefficient way of getting energy out of a molecule to burn it, because there's lots of heat energy dissipated to the surroundings. The internal combustion engine has lots of friction inside it. Therefore, we don't get as much energy out of the hydrogen as we could do. So there's a slightly different way that we can react hydrogen and oxygen together by not combusting it, but still getting all the energy out of it that we would if we burnt it, and all of that energy going into an electrical current, which then allows for a far more efficient transfer of energy from the fuel to the kinetic energy of the vehicle. So we're going to have a look at how that hydrogen fuel cell might work. So it's definitely possible to react hydrogen and oxygen together in a fuel cell to release the same amount of energy as internal combustion, but without the need for burning it. And you can kind of see what this might look like in the diagram. So you've got two electrodes connected to a circuit with maybe a light bulb, a motor, some other equipment in, and you feed the hydrogen and oxygen gas in. They react together, but when they react together, the electron transfer occurs through the circuit. So rather than being a direct transfer from the hydrogen to the oxygen, you're using the circuit to transfer the electrons. Therefore, you can get the energy out of the chemicals without the need for combustion. So we're going to have a look at a more detailed version of this and kind of look at the different stages that the hydrogen and the oxygen will go through to release that energy. So you might want to pause the video at this point just to quickly sketch what's on the screen, which is the layout of a fuel cell. The first step is that we add hydrogen, and this hydrogen will be coming from a fuel tank. So prior to starting the car, you would have filled up with some hydrogen gas, and that will be stored in a fuel tank. The hydrogen then transfers to the anode. When it reaches the anode, it ionizes. So rather than being a molecule of H2 covalently bonded together, it turns into some hydrogen ions and some electrons. And the half equation for this is on the screen. Now you'll notice the half equation has two molecules of hydrogen in, because if you look at the chemical equation at the bottom of the screen, we need two molecules of hydrogen to react with the one molecule of oxygen to make water. So to balance this overall, we need two H2s. I'm just going to show you what happens to one molecule of hydrogen through the circuit, but if you wanted to draw two, you're more than welcome to. So at the anode, the hydrogen ionizes, so releases electrons and turns into H+ ions. Those electrons are then going to transfer to the cathode, but doing so, they go through the electrical circuit. And that electrical circuit might have some headlights, it might have an electric motor, it might have a radio, it's going to have all of the components that the car needs to be powered. So the electrons transfer through the circuit, powering transferring energy to those items so that the car can move, and they then reach the cathode. At the same time that that's happening, the hydrogen ions are going to transfer through the membrane that separates the two electrodes, and that's called a polymer electrolyte membrane that only allows H+ ions to transfer through it. And those H+ ions, because they're positively charged, are attracted to the cathode where those electrons are now accumulating. At the same time that that happens, we're adding oxygen to our fuel cell. So I now have, next to the cathode, hydrogen ions, I've got oxygen and electrons. So I've got everything I need there to assemble a molecule of water and complete that chemical reaction. So that takes a molecule of oxygen from the air. It takes 4 hydrogen ions, which if you look at the half equation on the anode, you can see that I released if I had 2 molecules of hydrogen. I also then need to combine 4 electrons. Again, that comes from the half equation on the left-hand side, so everything is balanced. And when that happens, I create a molecule of water, or in the balanced version, 2 molecules of water. So what I've effectively done is react the hydrogen and oxygen together in stages. To react, I've got to take the electrons from the hydrogen and transfer them across through my electric motor, and then I combine them again with the hydrogen and the oxygen to make the molecule of water. The water then leaves the fuel cell through the exhaust as water vapour. And then I've completed my fuel cell. I've managed to react those two things together, release lots of energy, but I haven't produced any pollutant gases or anything that's going to be harmful to the environment. And if I then run out of hydrogen, I can just go to a new petrol station or hydrogen station and fill up my fuel tank again with more hydrogen. So just to kind of recap and make sure we've understood what happens at each stage. The first stage is the hydrogen goes into the anode and splits into H plus ions and electrons. You might call a H plus ion a proton because that is just a proton. That process is called oxidation. That happens at the anode. The second step then is that the electrons flow through the circuit, powering the motor, the headlights, whatever's in the circuit, and transfer to the cathode. The H plus ions, the protons that are made, flow through the membrane to the cathode. And they then combine with oxygen, with the electrons that we released earlier, to make a water molecule. And that process is called reduction because that's gaining electrons back into the chemicals. What we're going to move on to do now is compare that method of releasing energy from a fuel with some different types of fuel sources. So we're going to compare traditional fossil fuel vehicles, so that's petrol, diesel motors. We're going to compare battery-powered cars, so those that use metal-ion batteries, the ones that we looked at last lesson, and we're going to compare those two with hydrogen fuel cells, the type of fuel cell that we've just looked at. So it might be worth you constructing a table to make this easy to compare. So I've got my three fuel sources, my traditional fossil fuel, the metal-ion fuel battery-powered car, and the hydrogen fuel cell car. And I'm looking for advantages and disadvantages of each of those different types of vehicle. The things that you are going to consider are cost, reliability, availability of the fuel, how sustainable that is in the long term, how far the vehicle might be able to travel on a single fuel tank or a single charge, how easily available that fuel source is right now in the country, and other different factors to do with pollutant gases and where that fuel comes from in the first place. So I want you to pause the video, have a go at doing that, and then we'll quickly talk through a couple of advantages and disadvantages for each of those fuel sources. So let's have a quick look through some advantages and disadvantages. So traditional fossil fuels have a really high energy density in the fuel. They can travel really long distances on a single tank. It's very quick and easy to refill the fuel tank. That only takes a couple of minutes. The cost of the vehicle is much lower than the other type. So if you're buying a new car, it is much cheaper. There are some government incentives, so some grants that you can get to get money off the cost of those other vehicles, but it is still a little bit cheaper to buy an equivalent fossil fuel vehicle compared to a battery electric powered car. The fuel is cheap, and the infrastructure, the nationwide infrastructure used to distribute it, is in place. So there are petrol stations all the way across the country. The disadvantages are, as you probably can imagine, are that it releases lots of greenhouse gas when the fuel is combusted. It's definitely not a sustainable form of powering the vehicle because those fossil fuels are finite resources. As well as releasing greenhouse gas, it also releases, particularly diesel-powered cars, other harmful pollutants such as nitrogen dioxide, which cause breathing difficulties and particularly in large urban areas can accumulate to really high concentrations. Let's have a look at the traditional or more traditional battery-powered metal-ion car. So in comparison to fossil fuel cars, they release no greenhouse gases when they're running. And that doesn't mean they release no greenhouse gases at all, because fossil fuels might be used to generate the electricity that powers the vehicle in the first place. So it's important to make that distinction. They can be recharged at home, so there is the infrastructure in place for you to recharge at home. You don't need to go to a petrol station to do that. The cost of electricity is much lower per unit than the cost of the equivalent amount of fuel in terms of the energy that's released. There are no other harmful greenhouse gases released either, so nitrogen dioxide that causes breathing difficulties isn't released whilst they're running. At present, though, those vehicles can only travel quite short distances, or certainly shorter distances than the equivalent fossil fuel vehicles, and they have quite a long recharge time. There are some fast recharge points that can charge them in a much shorter period, but that is still considerably longer than the time it takes to fill a tank of fuel at a petrol station. The cost of the vehicles generally are much higher, although they are coming down as technology improves and they become more readily and easily available. If everyone in the country had an electric car, the current national grid infrastructure that we have in place would not be sufficient to handle the electricity needed to charge all those vehicles. So there would definitely need to be upgrading of our electricity network, the national grid, to enable that to be a nationwide mechanism of travelling. The metals used to make those fuel cells, or those electrochemical cells rather, are in finite supply. So there isn't an endless supply of those metals. They have to be mined, extracted from the ground. That's quite an environmentally difficult process to do. And when those batteries are disposed of, those metal ions can leach into watercourses and cause pollution as well if they're not disposed of correctly. It's also worth mentioning at this point that the lifetime of the battery powered vehicle is probably at the moment shorter than the fossil fuel vehicle. The battery needs to be replaced, whereas the fuel tank in a car definitely doesn't need to be replaced as frequently, so that adds to the cost. The third type of vehicle, a hydrogen fuel cell car, similar to the battery powered vehicle, creates no greenhouse gases when running, and that's an important distinction to make. They can travel longer distances on a single tank than the electric battery-powered vehicle, and they release no other harmful pollutants like nitrogen dioxide, so aren't going to cause breathing difficulties, and they can be refilled much faster than the battery-powered vehicle can be recharged. It is slightly slower than a traditional petrol station, but that's just because the infrastructure isn't as quick at the moment. The cost of the vehicle is much higher, similar to the battery-powered vehicles, and it is probably more expensive than a battery-powered metal-ion battery vehicle. The other difficulty that you would have if you tried to buy this type of car at present is there's no national infrastructure at all for the distribution of hydrogen. There are a very small number of refilling stations in the country where you can get hydrogen. Certainly in Cornwall there are none at all. So we would really struggle to have one where we are at the moment, but that's not to say that in the future that infrastructure can be put in place. The other big consideration is at the moment the power source that's used to create the hydrogen to go into that fuel cell probably comes from a non-sustainable fuel source. So it probably comes from a coal power station, an oil power station, gas power station. In the future, if the hydrogen is generated from a sustainable source like wind, solar, hydro, etc., then that becomes a much more sustainable way of releasing the hydrogen. So hopefully that's allowed you to compare those different fuel sources. There are other advantages and disadvantages that you might be able to think of as well. What I'd like you to do now is upload your work to show my homework, and you're done. Thank you very much for watching, guys.